Hello and welcome to Clear Water Quality. In the previous videos, I showed how to derive the lines that are drawn on a precipitation diagram for manganese hydroxide solid. In this video, I'm going to explain how to interpret the graph. So on the right here, I've shown the graph that I generated using our software. And I did add one line, which is at the bottom. I added a line for the total manganese, which is just the sum of all the other species, and that's shown as a dashed line here on my plot. Okay, so what this represents, each line represents a specific constituent and how it's in equilibrium with manganese hydroxide solid. So if your manganese is lower than that line, it won't precipitate, but if it's higher, it will precipitate. And what that means is that the, the lines define a region where manganese hydroxide is going to form, and that is right here. So the manganese hydroxide will form within this envelope. So it's defined like right here. And outside of the envelope, manganese hydroxide solid will not form. And so there's a couple of different ways to think about this. So at below this solubility or precipitation envelope, the reason manganese hydroxide is not forming is because the manganese concentration, dissolved concentration, is too low. So down here, low Mn concentration. So you don't have a solid, no solid. No solid is forming because the manganese concentration is too low. Over in this part of the graph, the pH is too low. So you don't have any manganese hydroxide solid forming. So the manganese hydroxide solid will only form if there is a lot of manganese in the solution and also the pH is high enough. And that's how magnesium solid is going to form. Now, of course, manganese hydroxide solid is generally undesirable in a water system because it can form precipitants that have some aesthetic issues, similar to iron. Okay, so within the precipitation envelope, we would describe the manganese as being supersaturated. Supersaturated. And what that means is, for example, if you're located somewhere within the envelope, um, it's supersaturated, so it has too much manganese. And what's going to happen is the solution, as it goes to equilibrium, is going to go towards the line. We don't know exactly how it's going to travel, but it's going to travel over to the equilibrium line, which is the CT value. If the pH stays constant, it'll just go straight down. Otherwise, it could go over in a different pathway. Okay, so outside of that envelope, our solution is undersaturated. So it's not forming the solid because it's undersaturated with manganese. So a couple of ways to look at this. For one thing, at what pH range can we precipitate manganese from our solution? So just looking at the graph, it looks like the pH must be above 7. Maybe, yeah, like about, I would say, about 7.5 for manganese hydroxide to form. Depending on what the manganese manganese concentration is. So for example, let's pick out an example. Let's say that our manganese concentration is 10 to the minus 4, which is right here. So if I go over here, that tells me that I need a pH of about, let's say about 9.7 for manganese hydroxide to form. So below that, it's going to be soluble. So in order to figure this out, you just look at where your CT is on the graph, and then you go over and figure out what is the pH that would cause it to start precipitating. Okay, and that's how you interpret the graph. Hopefully that's been helpful. See you next time.